Let's now solve some exam questions that use different methods of integration, from change of variable to integration by parts. We will know to begin with. The first one is this one, question weight. This is 8 from spring 2014, paper 33. You have here a fraction. Express this fraction, this function, in the form, and you have here the form. You should know that this is a type 2, not that it matters much because you have here the form already. So you just have to go and figure out the values of a, b, and c. Procedure is all the same. Multiply both sides by this denominator. This will obviously become just the numerator. In this case, it will eliminate the 2 minus x, leaving just the x squared plus 2. In this case, it will eliminate the x squared plus 2, leaving just the 2 minus x. This will allow you to eliminate this factor altogether by cherry picking 2, so this will be 0. So that happens when x equals 2. And this will become just 18 mine equals to 6a, which makes the a equal to 3. You plug it in over there and then expand the whole thing, combine the whole thing. Now compare the coefficients of each term. There is no term with x squared, so this must be equal to 0. The coefficient of x, so this stuff must be equal to 6, and this stuff must be equal to 6 as well. Solve the very simple simultaneous equations. Find the values of a, b, and c. There is a mistake here. This should be... I know there's no mistake. I have more equations than unknowns, and the a I already found. So b equals 3, c equals 0. Now that I know the three values, I should just substitute there, and this is what I get. The second part of the question was, show that the integral from -1 to 1 of that function equals to that 3 natural logarithm of 3. Okay, so I can go ahead and plug in already the result that I got before. I can divide this into two smaller integrals. This one is simple to find. Okay, you already learned this before. And this one is the one that involves the methods that we were talking about this chapter. All right, or not? No, not even this one. They are both simple to no, it is. Sorry. This is an integral of the form f dash of x over f of x. If you differentiate this, you look at that, and as you can see, this is one of the cases that you have in the MF 19. It's over here. All right, this is just going to be equal to the natural logarithm of f of x. All right, so natural logarithm of f of x, which is the part that you have in the denominator. All right, all of that between -1 and 1, then it's just a matter of substituting correctly. Do not mess up on this part and get the final result. Next one is spring 2015, paper 31, and we are looking at question 9. The diagram shows the curve y equals x squared times e to the power of 2 minus x and its maximum point m. Show that the x coordinate of m is 2. Okay, we already solved a similar question before on the, I think it was on the access frontier. This is a point, this is a stationary point, so as you know since last year, you have to differentiate the function and equal it to 0. That's what I did. Differentiate the function and equal it to 0. You have two smaller functions here, so you have to use the product rule. I use it straight away. So differentiate this times that plus this times that differentiated. That's what I did. So I just simplify over here, factorize what I can factorize, and once I have everything factorized, I equal each one of the factors to 0. The first one is 0 only when x is 0. The second one is 0 when x is 2. All right. This one is obvious, corresponds to this point over here, which is the 0, 0, the origin. This one is the one that we want. All right. So that's it. Then the next part of the question was find the exact value of integral from 0 to 2 of the function. All right, basically it would correspond to the area between here and there and the x-axis, that area over there. Okay, what type of situation is this? This is this type over here. Is integration by parts because it's a simple polynomial times a simple exponential. So your u is going to be x squared, your dv by dx is going to be e to the power of 2 minus x. You get now your du by dx and your v, the primitive of that. So this is going to be equal to u times v, so this times that, obviously within the limits of integration, minus the integral of v times du by dx, this times that, dx. All right, I already put the minus 2 outside. Sorry, the minus and the minus becomes a plus, and I take the 2 outside. So now I have this. And now I have, this can be calculated, this is going to be minus 4. But if you look over here, you don't know how to solve this again. This is one of those rare situations in which you have to apply the same rule twice in the same exercise. This is very similar to that. The difference is that this square disappeared and now you just have x. So you just go, this is still a simple polynomial times a simple exponential, so use the same method. U equals x, dv by dx is that stuff, so du by dx is 1 and v is that. The minus 4 just stays there. So this is 2 times v, your new v, your new u, all right? Your u and your v between 0 and 2, minus the integral between 0 and 2 of v times du by dx times dx. That's what it is. I already put outside the minus 2, and which multiplied by the other minus makes a plus. Then it's just a matter of integrating this, which is simple. All right, between 0 and 2, substituting and getting the value. All right. The only complexity of this question is that you will have to use this method twice in the same resolution of the integral. Last question. Spring 2011, paper 31, and it's question 7. The integral I is defined by this. Integral from 0 to 2 for t cubed, natural logarithm of t squared plus 1 dt. Use this substitution, it tells you what substitution to use, to show that I equals this. Okay, it tells me what to do and how to do it, so let's just take care of that. So this is the substitution that you have to use. So dx by dt is just 2t, which means that dx equals 2t dt. But now you have a problem. And the problem is that this doesn't resemble at all with that over there. Or better yet, it does, but it's still far off of what you need. You need 4t cubed, and this method only gives you 2t. So you have to fix the problem. You fix the problem of that. That is just going to be natural logarithm of x, right? But you are still missing what? You are still missing 2t squared, right? 2t squared times 2t gives the 4t cubed that you need. You are still missing 2t squared. So where are you getting it from? Well, if x equals t squared plus 1, then t squared is going to be x minus 1, right? Which means that 2t squared, the thing that you'll need, is going to be 2x minus 2, or 2 open brackets x minus 1. So you can get it from there. Before that, don't forget to get the new limits of integration. So when t equals 0, x equals 1. When t equals 2, x equals 5. These are going to be the limits of integration that you can see here already, right? I just broke down the function that you have over here into what you need already organized nice and neatly. This is 4t cubed is the same as 2t squared times 2t. I put this part over here because this is that, which is your dx. This is your x. And this 2t squared is going to be 2 times x minus 1. Natural logarithm of x dx, which is just 2x minus 2, natural logarithm of x dx as supposed. Then, hence, find the exact value of y. How much is that? Okay, let's integrate now. You can break this down into two fractions, and by the look of it, you'll have to, it's better for us to just do integration by parts twice, but unlike the other question, I'm going to break this down into two sections. So I'm taking care of this first, and then I'll take care of that, and then I subtract, okay? So this part, I'd send the 2 outside. I used u as natural logarithm of x and dv by dx as x. I get then the du by dx and the value of v. I apply here the rule, the integration by parts, and I can never forget the 2 that I have over there, right? So u times v minus the integral of v du by dx times dx. Then from this point onwards is just, I know I still have to take care of this integral, which is just x, simple enough. All of that is just substitution and nothing more than that. And yeah, and eventually I got this result over here. Don't forget, this is just for that. Now I'll take care of this one, which is over here. Again, I have to do integration by parts. I will put u as natural logarithm of x. We saw this in previous questions, and you already should know that your dv by dx is the one over there, all right? Eventually, one of the questions gave you a standard result in a case where the coefficient of x is anything else but 1 for any value a. Anyway, so the du by dx is just going to be 1 over x, and the v is going to be x. So apply the rule. This is v times x, sorry, v times u, minus integral of v du by dx times dx. This is just going to be 1, and the integral of 1 is just x. I'm just doing here the substitution, and here I have the final result for this part. So this minus that is this result minus that result, which is basically just this.